The 2018 Tesla Model 3 uses an electric resistance heating system, unlike traditional cars that rely on engine waste heat. This system converts battery electricity into heat through resistive elements. Common reasons for heater failure include software glitches that prevent proper operation. Blown fuses can interrupt the electrical supply to the heating system. A failing heater core may not generate enough heat due to corrosion or damage. Low battery charge below 20% can prevent the heater from activating to conserve energy. Intermittent failures can also occur in extreme cold, below -10 degrees Celsius or 14 degrees Fahrenheit, as the resistive heating rapidly depletes battery power. First, ensure your Model 3 is running the latest software, version 25.48.1 or newer, as of December 2025. Check for over-the-air updates through the car's infotainment system. A simple reboot of the system can sometimes resolve minor software glitches affecting climate control. Also, verify the battery charge is above 20%. Low charge can prevent the heating system from functioning properly. Check the vehicle's diagnostic menu for error codes using either the Tesla app or a third-party OBD2 reader. Error codes can provide valuable clues about the specific problem. These initial steps address common software and basic issues before diving deeper into the HVAC components. Locate the fuse box by referring to your Tesla owner's manual for its exact location. The fuse box contains fuses for various systems, including the HVAC. Inspect the fuse related to the HVAC system. A blown fuse is a common culprit and easy to replace. The system uses a glycol-based coolant loop. Ensure the coolant levels are adequate, as low coolant can prevent the heater from functioning correctly. If unsure about specific fuse and coolant locations, consult the service manual. Several components can cause heating problems in the Tesla Model 3's HVAC system. The heater core, an electric element that converts battery energy to heat, is often the culprit in older models due to corrosion or thermal stress. Blower motor failures can mimic heater problems, as they circulate the air through the system. If the motor fails, warm air won't reach the cabin properly. Malfunctioning thermistors, which are temperature sensors, and actuators that control airflow, can lead to inaccurate climate control. These components detect and adjust temperatures, but may fail over time. The control loop manages the entire system, but when components fail, professional diagnosis is often required to identify the exact issue. Some issues like blown fuses or software glitches can be addressed DIY. However, electrical work on a Tesla involves high-voltage risks. For heater core replacements, blower motor issues, or complex problems, consult a certified Tesla technician. Average repair costs for component replacements range from $500 to $1,500. Components like the heater core and blower motor often require professional attention. DIY repairs are trending in the Tesla community, but come with inherent risks. Weigh your abilities and safety carefully. For owners of 2018 Tesla Model 3 vehicles looking to improve heating efficiency, aftermarket heat pump retrofits provide a compelling solution. These upgrades replace the stock resistive heating system with more efficient heat pump technology, which can deliver 40 to 50% better efficiency compared to the original setup. Companies like Evolve and Zelectric Motors offer retrofit kits specifically designed for the Model 3. While this requires an investment, typically ranging from several hundred to over $1,000 depending on the kit, it significantly reduces battery drain in cold weather conditions. Heat pumps work by transferring heat from the outside air rather than generating it electrically, making them much more energy efficient. This means longer range in winter driving and less strain on the battery pack. Installation of these retrofit kits is typically a DIY process for experienced users, though professional installation is recommended for most owners. The process involves replacing key components in the HVAC system and integrating the new heat pump controls. For real-world experiences and installation guides, check online communities like Reddit's r/Tesla Motors and the Tesla Motors Club forums. Users share detailed installation walkthroughs, cost breakdowns, and performance results from their upgrades. Regular maintenance is key to preventing heating issues. Perform annual coolant flushes to prevent blockages in the heat exchanger. Utilize the Tesla app for preconditioning the cabin before driving, which can extend heat duration by 10 to 15 minutes and reduce battery drain during cold starts. Stay updated with the latest OTA software updates, as Tesla frequently releases fixes for climate control glitches. For example, the 2024 V12 software update introduced adaptive heating algorithms which optimize energy use. The future of EV heating focuses on efficiency and sustainability. Trends point to widespread adoption of solid-state heating elements and better battery insulation in newer Model 3 refreshes. Tesla's integration of AI-driven predictive heating is also promising, learning from user data to preempt failures. Monitor user forums for DIY fixes and community-driven solutions, especially for legacy vehicles. Keep an eye on industry reports for advancements in EV heating technology, potentially reducing energy use by 60% by 2030. This also highlights the environmental importance of recycling heat from motor inverters to ensure carbon-neutral operations by 2030.